Hi everyone, and welcome back to my devlog. If you're new here, I post weekly videos logging the progress of the new third-person looter-shooter mobile game I'm developing called N.E.S.T, so consider subscribing to follow along. I started off this week by adding the consumables I had modeled last week into the game, and implemented their functionality. Health items such as plasters, bandages, and first aids immediately restore a fixed amount of health, while boosters like energy drinks, painkillers, and morphine injections regenerate health over time. I then assigned all of the sounds I had organized in the previous devlog to each of the different aliens. While I had already sorted out what their ambient, roar, and death sounds would be, I still had to go through each of their different attacks and match them to sound effects. Since the release of Star Wars Fallen Jedi, I've been watching Jack Fraggs' playthrough of the game. In light of this, I decided it was time to add some melee weapons into the game, and I've currently added 34 for players to collect. Now, you may be hesitant to bring a sword to a gunfight, but there are definitely a few strategic reasons to using them. They're silent and have unlimited uses, meaning that there is no need to worry about ammunition. In some instances, it may be necessary to preserve ammo and use your melee weapons when fighting melee enemies, keeping your guns for the ranged enemies. It might also be essential to keep a melee weapon on hand in order to destroy the nest at the end of the level when you're all out of ammo. Anyway, just like Minecraft, I decided to use a ray casting system in order to determine whether or not you successfully hit an enemy. In order to use your melee weapon, you hold down on the action joystick to lift it up, and then release to swing. Next up, I wanted to work more on the AI for the aliens. It didn't make sense that ranged enemies immediately rush towards the player. Instead, I made it so that those with ranged attacks prioritize these attacks at the beginning of a fight. If, however, the player moves close enough to the alien, they will proceed to their allocated melee attacking position. If the player then manages to run away from the alien, they will return to their ranged attacking position. This feels much better in-game, and adds a whole new dimension to the strategy when playing. My next task for the week was to finally design an actual level. If you watched my earlier videos, you'll remember that I modeled the crater by hand. At the time, I thought I couldn't use Unity's terrain tools, because it always smoothens out the normals, making it impossible to achieve the low poly, faceted look. Even when you convert mesh data made in Blender into a Unity terrain object, it will smoothen out the terrain. My first approach was to therefore make low poly terrain by hand in Blender, but this was very time consuming to make, and didn't feel natural at all. I then tried making the terrain using Blender's sculpting tool instead. I struggled the entire day, however, to get the shape of the crater right, and get the ridges to show while keeping everything low poly. So I did the sensible thing and asked online. The next morning, I was happy to see a nicely detailed answer, where they explained how to achieve this effect. Their solution was to download a height map of the Barrington crater, and then import it into Blender. I could then use the decimate modifier to achieve the low poly look. I tried this out and it worked great, so I imported it into Unity and began designing an actual level. I then hit another brick wall. Because I wasn't using the terrain system, I couldn't simply paint grass and trees onto the scene using Unity's tools. This is crucial because of the way these tools actually work. Instead of simply spawning a large number of grass prefabs into the scene, which would be terribly inefficient, they use shaders and GPU instancing to render multiple copies of the same grass mesh at once, using a small number of draw calls. I'm unfortunately not experienced enough with shaders to tackle this on my own yet, so I needed to think of something else. I decided to just go ahead and watch some low poly level design videos to see how they achieved this. To my surprise, I saw most of them were actually using the Unity terrain system. Funnily enough, the terrain that a lot of low poly games use are in fact high poly And so the following is the workflow I came up with for designing crater levels for my game. Hold that right there. While editing this video, I found an asset called Polaris, which is a low poly terrain engine. I'll look into it, and if it fits my needs, I'll take advantage of the Black Friday sale which starts tomorrow, and purchase it. Before I end this video, I want to speak about what I'm planning on doing in the following weeks. I need to spend some time and do some spring cleaning, such as organizing my project, tidying up some code, and also fixing some bugs. That being said, I don't think I'll upload a video next week. Instead, if anything important comes out of it, I'll speak about it in the next devlog. I also want to spend some time and make a public Trello page as well as a Discord server. I want to actually try and get a demo out soon to you guys to test it out on your phones. Those in the Discord server and who follow my Twitter will be the first to know when this short testing phase starts. So make sure you're there, because there will be a limited number of slots available. But that's going to do it for this week. If you enjoyed or learned something, make sure to slap that like button and subscribe to follow along on the development of this game. Anyway, thanks so much for watching, and I'll see you in the next one. Take care.